Hello and welcome back to the channel. This is the second episode of my Node.js with TypeScript series. And in today's episode, we'll talk about stuff like process in Node.js, modules, and simple write and read operations. Okay, I bumped up the font size from last episode, and I hope all of you can read just fine. Okay, so within every Node.js program, there's this global thing that is called process. So we don't need to require it. I just can type process here. And as you can see already, because we are using TypeScript, our program will, Visual Studio Code actually will throw off some error that it cannot find the name. Of course, it can be fixed easily. We just need to add types for node to our program. So types, no, I believe that's the one. And this will install the definitions for node and the problem goes away. So let's run that. Should work out fine and spit out a whole lot of properties and about our process. So let's discuss a little bit what it is. As I said, this is a global variable and it is used to communicate with the outside world of your program, meaning it has access to the informations and functions that are available to you via the Node API to communicate with the underlying OS. And there's a lot you can get out of it. The interesting things, for example, is the PID entry, and PID is the process ID, meaning the unique identifier that identifies your running program inside of your operating system. And if I log just that, we'll get a random number, and as you can see, it differs from run to run. And often is that PID is used for stuff like killing given program when it's stuck. You can find a program running in your OS by using the PID. The one interesting thing that you can do is actually listen on some events that are happening in your program, because Node.js is event driven, and there's a lot of events that can happen inside of a program. One that is kind of cool is process. You can add listener on exit or before exit, and thanks to the power of TypeScript, we already have most of our names for events how to complete it for us. Let's see. We are about to exit the program, and then there's exit. We will exit the program now. And if I run it, you can see that this adhere to the lifecycle in the proper order. So first there's a before exit, and then there's exit. And this pattern is very common in programming. You're being informed when something is changing or happening. In the older React versions, you had the life cycle for a component with the component did update, component will unmount, and so on. And now we're, of course, are using hooks and use effect hook for that. But still it goes through the same flow of mounting, unmounting, and so on. The same happens here with before exit, exit, and other events that are happening in your program. And you're informed about this via the listeners. So there's another important thing we could add here. Let's create a function, call it div. And as you all know, you shouldn't be able to divide by 0. Right? And in our cases, it would be rather fine to do the operation. But here, we should handle that somehow and inform our user that the program didn't finish properly. So on our process, there's a method called exit, which will terminate your program, and it will with a code. So by default, when our code is run through and we go to the very bottom, you don't see it, but it actually exits our program with exit 0, meaning everything went fine. But let's see what will happen if I provide another code. For example, -1. Let's run it with 2 and 0. What we get actually is called error lifecycle, some kind of error number, and the information that this is probably not a problem with npm. There's a log, which is cool and stuff like that, but this indicates that there was some kind of error. Of course, if I change it to something like 4, right, it still fails exit status 4 because it wasn't 0. Okay, so what if instead of exiting program here with some kind of error code, I would like to throw new error. Let's say just can't divide by 0, right? One approach to handle that you might like to do, just by default wrap it in catch, try catch closure, and let's just error that, right? That's pretty basic stuff. And yeah, we catch that error. But there's a way to catch the errors globally, right? Because the errors in your program, you're not always able to predict those. So it's good to have some kind of last line of defense against exceptions that were not caught anywhere else in your program. And we can do that by adding another listener, say here, And the event we're looking for is uncount exception. And what we can do here is, for example, error something. This should have been handled somewhere. I believe there should be an error argument here. And we'll process exit with -1, right? Because we know that's an error. Try this now. Okay, there's an error, right? And there's also information this should have been handled somewhere. And as per the thread, yeah, we even have the type here. It's the type of error which we display here. Okay. So if you take a look at the process here, there's actually a lot, and I'm not gonna be the one to go through all of this because, as always, there's we'll learn it as we need it, right? The process kill, as I mentioned, you can kill a process if you pass the PID. So there might be a situation where you spawn a lot of processes and then you have some kind of master process that is able to kill its children, right? That sounds bad, but anyway. Okay, so that's about it. One thing that I assume you already know, but I will mention it quickly. When you're building your app with React, the one common pattern that we always do and use is the use of modules, right? Basically, every single component that you create is in a separate file, and that file in itself is often a module. The same goes for Node.js. You can use modules here, and you should separate your code. Basically, out of the box, you can use the old syntax, meaning let me just create a write file here. We'll use it to write some stuff to the file. You would create something like right. And if I'd like to use that function here, I have to import it somehow. And out of the box, you can use module exports syntax to export the write, and then require here. So it's gonna be something like require write if I understand that correctly. Can redeclare. What's that? Another redeclare. Oh, it was okay as that. Yeah, okay, I have to rename it for any reason. Let's see. And I expect to have the console log here now. So I created a function, I exported it using module exports, then I imported it, given the path, name it, and let's run it. I'll write to the file. Okay, that works. So you can use that, I believe this is ES module syntax with require and module experts, but what is commonly used in nowadays applications is the import export syntax, right? You know it if you ever created any app with create React app. So what I would like to do actually is something like this: export, and then of course import from, right, and this should be right, and now it doesn't present any error on load. So when you're using TypeScript and TS Node, you can use the module syntax that you already know from Create React App. So this is cool. This will work. So maybe let's focus on writing stuff, right? This is one of the basics operations. And what we could do here is just write something to the file, and I will write it using promises, because again, historically, Node.js was basing its async operations on callbacks, and as you know, this can be problematic. The codes tend to be complicated, especially because of the callback hell that you can stumble and create yourself, right? So the better way is, of course, to use async await or promises that we know and we like. So what you can do is just import from fs promises, and then you can get write file, and basically what you can do is write file. Here you can provide a path. Let's create txt, and let's say cyberpunk, right? One problem here, it will work, but it's not correct. If you check the method and the types for it, it will return a promise void. So we should make our function async await here. Okay. So let's see. Maybe that will work. And amazingly, did. We have now a file with the entry. So one thing to note here is that write file will create a file for you if it doesn't exist to fill it with the content, right? So there ain't gonna be a case when you're trying to write to a file that does not exist. Okay, so that's good. Okay, so let's enhance it a little bit, and I will pass a game title here. Then of course I can pass a name here, and let's say, for example, draft. But that feels pretty static because we're just passing a string, and what I would like to do is to read the information from the user, okay? And this can be done using the console. We just need one thing imported of it, and this is create interface from readline module. So let's see. Do that to create interface, readline, and here when you're calling that beautiful function, we need to provide input and output. And if you'd like to read from what user is providing to the screen from his keyboard, we're using process, and this is stdin as standard input. Then we also need to provide output. This is going to be standard output. And here, what we can do is create a question for our user. What's your favorite game? And there's a callback. As you can see, I mentioned here that Node.js out of the box is working with callbacks, which for me more than comfortable, but for the sake of the tutorial, let's just go that for a second. So once we have an input, we can write our game, and then we have to close our readline, because that's basically I believe we have to close it because it's some kind of stream. I'm gonna assume that. Okay. Let's see. Let's run our program. Should be asked about our favorite game, and this time I'm gonna type satisfactory, and on enter, it should be in our list.txt file, which is. Okay, so that's how you can get the input from the user. Is there a better way to do that instead of using callbacks? And I believe there is. Let me just find it. There's a package called inquirer.js. Oh. Fire. Okay. Right. And it should work pretty good with the promises. You can validate, kind of cool. Okay, there's a list, input, all of that. So let's try using this. I will install inquirer. How we spell that? Looks like it. There's a prompt. Okay. That port from inquirer. The question is, okay, looks good. So inquirer. Oh, we need types. right? We'll make it work with TypeScript. Yeah. Prompt. Here we have questions. And the question is, let's check. Pass your questions. A question is an object type. Message. Question to print. Okay, so type is put. Then there's message. What your favorite game? And the prompt should return a promise. Get rid of that for a second. And let's say that this is answer. Just log it, and of course we have to await. And we can we await? No, we can't, but there's always a way to fix that. Or create and run function. Be async function. Always a way to cheat a little bit. So if you want to run an asynchronous function, the top level of your module, you just create a function and make it async, and then you run your code inside of it. So okay, and only this module interop flag. Not cool. Can we do prompt then? That. So must provide a name parameter. Okay, cool. Not a problem. Anything you want. And oh, this is very nice. So let's see. This escape from Tarkov. Okay, and it logs the answer with the given name. So let's try writing that. So write answer game. And here you can see that the prompt actually is generic function. And that's why you don't get the key auto-completed here, right? I can see that the key is game, and what we get as an answer is actually an object, but I would like to define the structure, the type for it. You can fix it, I believe, very quickly just by defining the interface answer, and it should have game of string. And since this function is generic, I can put it right here. And then, as you can tell, I get my autocomplete. Beautiful. Okay, let's run it. Let's see, escape from Tarkov. For now, this is satisfactory, and after I press enter, this is escape from Tarkov. Okay, and I believe this episode is long enough, so maybe in the next episode we'll focus on reading the file. and appending to a file. Well, more file operations incoming in the next episode of Cyber Potatoes. So remember to like and subscribe, maybe comment, and let me know what would you like to see in the future. Goodbye.